Hi everybody, this is a quick review of nomenclature or naming a chemical compound. We're going to focus on inorganic salts, right, because they pop up quite a bit, and have a little bit on some organic stuff. Remember when we talk about salts, the positive ion goes first, negative goes second. The positive one in most cases is a metal. The second one is a non-metal, but there are some exceptions. Okay, we'll also talk a little bit about organic, things like dinitrogen pentoxide or carbon monoxide, some of the basics. So this assumes that if you had 1211 last semester, did well, and are comfortable with this, you may not need it. It's still a good review. If you haven't had chemistry in a while or you didn't do well in this part, you really need to know this in detail, right? This is like step one in a lot of problems that are 4 or 5 steps, and if you get this step wrong, everything else is wrong. Okay, so a quick review of some of the anions. Nitrate is NO3 minus, oxide is O2 minus, phosphate's PO4 with a -3, hydroxide base is a minus, sulfate SO4 -2, sulfide IDE -2. You'll notice that when it's an element by itself, like sulfide, chloride, fluoride, it ends in IDE. Carbonate CO3 -2. When it has an H in front, it's bicarbonate. So remember, these are chloride, fluoride, bromine, iodines, and when they're gases, they're diatomic, right? Cl2, so you say chlorine, but when it's an ion, an anion, it's a chloride, it's a halide. Ammonium is NH4 plus, right? IUM. NH3 is ammonia, IA. Permanganate, that's NATE, right? MnO4 minus. Nitrite, ITE, is NO2 minus, right? So this is different than nitrate, which is NO3 minus. Sulfite, SULFITE, is SO3. Remember, sulfate with 4 is more common and ends in ATE. Chromate, CrO4 -2. Perchlorate, ClO minus. Okay, so remember when we come up with empirical formulas for salts, what we do is we look at those charges up on the top. So for example, calcium is in the second row, so it's always a +2, and chloride's always a minus, and then you crisscross, right, and you get CaCl2, okay? That minus goes away when it goes down here. And so there's 2 chlorides, -1 plus -1 gives you -2, and 1 calcium, which is +2. So +2 -2 gives you 0 charge on that molecule. Okay, so let me show you something really quick on the periodic table. Okay. So remember the rules of thumb here. This first row, lithium, sodium, potassium, rubidium, cesium, or alkalis, they're always +1 when they're in a salt or dissolved in water. Okay, this second row here is always +2 when it's in a salt or dissolved in water, right? Calcium +2, magnesium +2, right? And that's alkaline earth. Here you have the transition metals. They're positive, but they can be typically anywhere from +1 to +6, and that's when we use the Roman numerals, right? So you would have iron. You would write it like as iron 2 if it's a +2, right? Or iron 3. Okay. Now the 3 that never change in salts. Aluminum is +3, zinc is +2, silver is +1, 3, 2, 1. So a lot of times you're supposed to write the Roman numeral, but a lot of times since they're always the same, that people will not. So that's +3, +2, +1. And remember, so there's some trends, like iron is almost always +2 or +3, right? If you come down here, say to tin is +2 or +4. All right, copper is +1, +2. So some of these have the same numbers over and over again, but then you can have, say, something like tungsten, which can be anywhere from +3 to +6, right? It can be all over the place, depends upon what it's bound to. Okay, so those Roman numerals get used with the metals. They also work down here with the lanthanides and the actinides, but we just don't talk about them as much. And this row right here, so these are artificial elements, have only been made in nuclear power plants, and so we don't talk about their chemistry much either. Okay, so let's go to the next page. Okay, so just a real quick review. So remember that Roman numeral tells you iron +3. Carbonate, this is why you have to have them committed to memory. CO3 with a -2 charge. You crisscross, the 2 goes to the iron, the 3 goes to the whole carbonate, right? So you have to have carbonate in brackets, right? So this tells you have 3 carbonates. If you didn't have that bracket there, it would look like CO33 or 33 oxygens, right? Which is clearly wrong, right? So here you have a salt again, copper plus 2 with carbonate, and so you notice that's a 2 to 3, so we can't break that down any smaller, so that ratio is going to stay there. But here we have copper plus 2, carbonate minus 2, crisscrosses, right? And remember that 2 goes to the brackets, that's a 2 to 2 ratio, and when you have salts, you can only do this with salts, that 2 to 2 ratio breaks down to a 1 to 1, so you actually write it like this, copper 2 carbonate looks like that. Okay, and the reason for that is when you have salts, they're not really individual copper carbonate molecules. They're repetitive structures, right? Copper carbonate, and that's what's in the salt. Okay, and then when you put this in water, right, it dissolves and it breaks up. So that's just telling you the ratio of copper to carbonate in your repetitive lattice or your repetitive salt. Okay, so they're not really molecules, like say CO2 is a molecule by itself, or H2O is a molecule by itself, and so you don't change those. Another great example of a molecule by itself is hydrogen peroxide, right? H2O2, you don't reduce that, because that's what hydrogen peroxide is. It's a molecule that looks like this, right? And you can't reduce it, right? So that one molecule can float off by itself, whereas here, remember, this is a repetitive structure, okay? So just pay attention to that you don't reduce those subscripts when they're typically nonmetals, but when you have salts or ratios of positive to negative, you can break them down to their smallest numbers, all right? So let's look at our next one, okay? So just to kind of go through a few of these, so calcium phosphate, calcium's in a second row, so it's plus 2, phosphate PO4 minus 3, you crisscross 3 to 2, remember that's 2 phosphates, it's not PO42, it's PO4 2, okay, and you can't reduce 3 to 2 to anything else. Nickel 2 oxide, nickel's plus 2, oxide's minus 1, you have the 2 to 2 ratio, you break that down to 1 to 1, so that's a salt. Remember, salt is a cation with an anion in a repetitive structure, like in a salt. Sodium sulfate, sodium's plus 1 because it's in that first row. Sulfate committed to memory, SO4 minus 2. Crisscross, you get 2 sulfates for one. You get 2 sodiums for 1 sulfate. Aluminum oxide, remember, aluminum, a lot of times it should be plus 3 here, but a lot of times people don't write the plus 3 because they know it's always 3. So aluminum's plus 3, oxygen's minus 2, crisscross, you get Al2O3. Okay, so when you look at this part, you get aluminum plus 3, zinc plus 2, silver plus 1. That's on a periodic table, that kind of stair. And they're always that, and so a lot of times people don't write that Roman numeral there. Silver plus 1, chloride minus 1 makes that. Okay, so we have similar things here. We have barium sulfate. Barium's plus 2, sulfate's minus 1, breaks down, gives you a 1 to 1 ratio. Okay, so barium's in the second row, so it's always plus 2. You don't have to write the Roman numeral. Iron 3 hydroxide. Iron's plus 3, hydroxide's minus 1. Remember, you don't write the 1 there, it's just a negative. Crisscross, that negative goes away. Right, there's no negative down there because you're counting things. You can't have a negative atom. Magnesium nitrate. Right, so magnesium's in the second row, plus 2. Nitrate's always NO3 minus, crisscross. Right, you get that, and it's magnesium nitrate. You don't have to put the Roman numeral because it's in the second row. This is ammonium, IUM, pretty common in salts. And this is chloride, so it's a plus 1 minus 1. They crisscross, ammonium chloride. Right, so you can go to the stock room and get a salt, a solid, that's ammonium chloride, but ammonia, NH3, doesn't form salts, right? Or at least not small salts like this. It can be involved in what's called coordination complexes that we'll talk about later, okay? But they are not the same. Okay, so some organic stuff. Remember, mono is 1, carbon monoxide, di is 2, carbon dioxide, so it refers to 2. 3 is like PCl3, phosphorus trichloride 3. Tetra is 4. All right, carbon tetrachloride, right? You notice that these are all non-metals, right? They're all from this part up here on the periodic table. So when you have this, like if you have, SO2, it's sulfur dioxide, but if you had like CuO, it would be copper 2 oxide. So over here you use the mono-di-tri. Over here you use Roman numerals when you get to the metals. Okay, so this is the non-metal and the metalloid region here. All right, these are your inert gases and those are your halogens. Okay, so 5 is penta, right? And so when you have two nonmetals like this, N2O5, because you don't typically say monophosphorus or monocarbon, but when you have two here, you have dinitrogen pentoxide. There are some cases where you might use these in a salt, and probably a common one is uranium hexa 6 hexafluoride. So the formal way would be to write it with the Roman numerals, but a lot of times people write it hexa. Sometimes it's even just called uranium hex, if people know what it is. SF6 sulfur hexafluoride. Okay, so two nonmetals. Some other common ones. NH4 plus, right, is ammonium, NH3 is ammonia. So this is hydrocarbons. So methane is one carbon. Carbon likes 4 bonds. It can be 4 single bonds. It can be 2 double bonds. It can be a triple and a single. Different ways, but carbon likes to have 4 bonds. Ethane is C2H6. This is actually not butane. This is propane. Okay. Butane is C4H10. This one's propane, A-N-E, that's an E. So when you have an OH like this, this is an alcohol. So that's methanol, right? Methane, methanol. This is ethane, C2. So that's CH2, so that's ethanol. If you made propane into an alcohol, it would be propanol, OL at the end. These are some of your common acids. HCl is hydrochloric, H2SO4 is sulfuric, H3PO4 is phosphoric, HNO3 is nitric, H2CO3 is carbonic, and H3PO4 is phosphoric acid. Okay, so that's kind of a quick review of the nonmetals and the acids. All right, so let's look at, so take a second, and I'll say if you want to practice, here's some practice. So first one, CuOH2. Right, and I'll give you like 5 seconds to write it down. So CuOH2 is copper 2 hydroxide. Okay, next one, HCl is hydrochloric acid. So NO3 by itself is nitrogen trioxide. It has no charge. That's a real molecule. It has no charge. It's nitrogen trioxide. NO3 with a minus is nitrate. So rule of thumb, when you have nitrogen oxygen compounds that are pretty small, that they are gas phase. When you have something with a charge like nitrate or nitrite, it's going to be dissolved in water or be in a salt. Ke is, now look at the periodic table, Ba is in the second row, so it's always plus 2. Right, sulfate's SO4 minus 2, so that's barium sulfate. Okay, and you don't have to say the 2 because it's in that second row. Iron is a transition metal, so phosphate's minus 3, and so this had to be a plus 3 to cancel out to get that 1-to-1 ratio. So this is iron 3 phosphate. SO2, right, 2 nonmetals, so that's going to be sulfur dioxide. This is propane, C3 with an OH, so this is propanol. And since this is on the first carbon, it's 1 propanol, so propanol. Okay, so the next one is sodium hydroxide, common base. Remember, hydroxide's a base. H2SO4 is sulfuric acid, all right, common strong acid. There's 7 strong acids, literally millions of weak acids. So you remember the strong. Remember, acids, most of them have an H first when you write the empirical formula. This is ammonium nitrate, right? So ammonium nitrate. This is +1 -1, so it broke down. And then this next one is zinc. So remember, zinc is always +2, but the formal way to write it is zinc 2 sulfide, SULFIDE, sulfide. So zinc 2 sulfide or zinc sulfide. All right. And H2S, if you look at sulfur on the periodic table, it's right under oxygen. Right, so H2S is hydrogen sulfide. Our nose are very sensitive to it, right? You can smell it very easily, right, at parts per billion type level. This goes into the gas phase pretty easily. Okay, H2S is hydrogen sulfide. All right. So that's a quick review of those things. If you think like you have a lot of problems with them, just go into the book and look under nomenclature and you'll find them. Thanks very much. Bye.